Hello class, so in this video we're going to be going over the first of many integration techniques called the substitution rule. It's also known as u-sub or u-substitution because we usually use the letter u to substitute, and that's the variable that has just been traditionally used for reasons. Alright, so what I want you to first do is try to compute each of these in 30 seconds each. I'm going to give you 5 seconds to pause the video and try it and then restart. Alright, so I'm going to assume you've already paused and tried it, and you can probably see where this is going. Alright, so this one, easy. E to the x plus c, right? This one, not so easy. But there are some things that can give us some hints. We know we're going to have an e somewhere because the only way that you can get e in the integrand is by having e out here and somehow differentiating it. And in order to get an e to the x squared, you're going to need an e to the x squared here somehow. But then what else do we need? Well, if we take the derivative of that, we get e to the x squared times 2x, which is not the same thing, it's the same thing times 2. So, well, what if we just took 1/2? Then we get x e to the x squared. Okay, so that works. But that's not necessarily something that would have been easy to see immediately. So let's try to figure out a better way to do that. So we just used a chain rule. So let's try to reverse it. And essentially here's the technique that you want to use is going to only work if you have a function in a function and somehow one of those parts, if you take the derivative of it, you will get the outer part that is not part of that times dx or whatever original variable it is. So let's just look at this and try it. Okay, let's look at this. What do we have? We have something that looks kind of disgusting at first, but notice that x squared plus x minus pi will be differentiated to get this, because you got 2x plus 1 plus 0. Alright, so let's just let u equal that and see what happens. Okay, so let's take the derivative of u with respect to x. We get 2x plus 1 minus 0. So in other words, du equals 2x plus 1 dx. And the perfect thing is we see all of those parts here. We get 2x plus 1 dx, and we get x squared plus x minus pi. So this becomes, whoops, colors. So that becomes the integral of 1 over u, and then that whole thing just becomes du. So we get ln of u plus c. Well, the question is, what is u? Well, that. Just literally put that in there. Plus c. And that's it. Alright, so let's look at the next one and see how that works. Because you might be thinking, how does it work with limits of integration? Well, let's try it. This one is a little bit tricky, so I wanted to do this also because it'll show 2 different lessons in one. Sometimes you're going to have to use the u and substitute it in different ways. So I'm just going to say that x also equals u minus 2. That makes sense there, right? Just if you subtracted the 2. Then let's look at what happens. Du dx equals 1, sorry. 1. So in other words, du equals dx. So this thing is just going to turn into du. Sorry, the computer just did something weird. So hopefully you didn't hear that, but oh well. So let's see. The reason why I did this is because the bottom, that's going to be u, right? That literally is u. But the top, not exactly. That x can become u minus 2, so let's just do that. And then the plus 4, nothing else happened with it, so let's just leave it as is. And then the dx, that actually just became du. Okay, so let's see what in the world is going to happen with this thing. Oh wait, we forgot one thing. The limits of integration. So what happens here? Now the variable is u rather than x. So that's going to turn into, let's see, x plus 2. So we can take an x and turn it into a u by just plugging it in there. So there's going to be 2 to 3. Okay, so actually let's simplify it over here and then see what happens there. That's going to be u squared minus 4u plus 4 plus 4 all divided by u du integral from 2 to 3 then of, let's see, let's just simplify that more. 4u plus 8 over u. Okay, so at this point you might be like, well, what do we do here? We can actually split that up. So notice that everything has a common denominator, which is u, so we can just split it up like this. U squared over u minus 4u over u plus 8 over u du. Alright, so I'm just going to simplify it real quick before I integrate it. So we will get that. And now this is a lot easier to integrate, right? So that's just going to be u squared over 2 minus 4u plus 8 ln of u, all integrated from 2 to 3. Alright, so let's see, what do we get? That'll be 9 over 2 minus 4 times 3 plus 8 ln of 3. And notice I don't absolute value that because it's already positive, right? Minus, okay, 2 squared. We're just going to put 4 over 2 minus 4 times 2 plus 8 ln of 2. Alright, let's try to simplify this as much as possible. The reason I left this as 4 over 2 is because we can more easily... I would have had to reconvert it anyway. Okay, so 9 over 2 minus 4 over 2 will be 5 over 2. Let's see, negative 12 plus 8, so that'll be minus 4. Plus 8 times ln of 3 minus ln of 2. So let's see, that's 8 over 2, so then negative 3 over 2. Plus 8 times ln of 3 over 2, and yeah, I think that's the most simple form we can get it into. Alright, so I have another one then. Or do I? Yes, I do. And this one is going to be a double u-sub. So this will be interesting. A lot of color coding is going to go on here. Okay, so first thing is let's just let u equal this thing, because we're going to be able to get that 2x somehow through differentiation. So du is 6x dx. So that's going to be what u becomes, and then basically that is going to be what dx becomes. So let's see, let's make that exactly the same. So this will be, in order to get 2x dx, we have to divide 3 to the other side. So what we end up with then is the integral from, okay, so what's this going to turn into? So plug in 0 there, we get pi. Plug in pi there, we get 3 pi plus pi, so 4 pi. Okay, this will be interesting. And then we'll have sine of u times cosine squared of u. And then our du is also going to be divided by 3. So let's just multiply that 1/3 in front. And then, let's see, can we integrate this exactly? Not quite yet. So let's do another layer of substitution. So I'm going to use the variable w and let that equal, let's see, cosine, because that's the one that's inside of a squared function, right? So dw equals negative sine of u du. Okay, so let's see. Now we're going to have, oh, I should have done that in a different color, red. Just for color coding purposes. Okay, so that negative one, that 1/3 is going to become negative as a result of all this. Now the limits of integration are also going to change. Okay, cosine of pi is -1. So that, and then cosine of 4 pi is 1. Okay, cool. And then cosine squared becomes w squared. And then finally we have our dw. Okay, so a lot going on there. Notice there's no more yellow here because the u is kind of inherently inside of the w, so yeah. So let's just compute this thing. So we get -1/3 times w cubed over 3 from -1 to 1. Okay, so we get -1/3 times, okay, so that'll be 1/3 minus -1/3. Yes, yes, yes. So that'll be -1/3 times, so that'll be, whoops, 2/3, and then we get -2/9. That should be correct. Alright, so that was a bit of a crazy integral, but notice it's just 2 levels of u-sub are not necessarily too bad. It's just you gotta keep track of things. I don't necessarily suggest color coding everything, but just at least doing some sort of thing so that you can stay organized. So if you do let this, let this, that's good. Just don't write everything everywhere and make it a mess. Alright, so that's the end of this. Hopefully that was helpful, and I'll see you in the next video.